Now in 8.3 we're going to look at reflecting points and graphs, but first we're just going to look at reflecting graphs. And the rule of thumb for reflecting the graph of a function is if you make the x-coordinate negative, it flips you over the y-axis. So in other words, if you've got a negative on the inside, that's over the y-axis. And if you've got a negative outside, that's equivalent to making the y value negative, which would flip you over the x-axis. So example A, we have the graph of our parent function, y equals negative 5 plus x in black, and its image is shown in red. First, we need to describe the transformation, and then we need to write a function. So if we look here, notice our x-intercept here is at 5, and then it's flipped over to negative 5 here. And if you look, every point on the parent gets flipped to the negative x value for our new function. So that means since we are flipping over the y-axis and our x values are becoming negative, we want a negative on the inside. So the way we would write that is y equals negative 5 plus a negative x. For example 2, we have our parent function, absolute value of x, and we've got our new function that has a reflection and a translation. So first we should notice that we are flipping downwards, or flipping over the x-axis. That would be a reflection. And not only that, but we have also shifted down 1 and left 4. So that means we're going to follow our rules from the previous section and add in the reflection. So a reflect over the x-axis means that we have a negative on the outside, and our down 1 and left 4 happen by adding 4 on the inside and subtracting 1 on the inside. So our final equation is as follows. We have y equals our negative on the outside. We need to go left 4, and these should be absolute value signs here, and then we're going down 1. Now I'm going to have you follow those same rules for our guided practice problems number 1 and 2, and when you're ready to check your answer to 1, you can unpause the video. Our flip over the x-axis puts the negative out front, and our translation of up 4 gives us a plus 4 on the outside. So our graph, we have gone from our 0, 0 vertex up 4, and then instead of opening upwards, we are opening downwards. Now go on to problem 2. So we've got a reflection over the y-axis, which means we've got a negative attached to the x on the inside, and left 2 tells us we add 2 on the inside as well. So our final graph here just looks like a shift to the left 2, and that's because our flip over the y-axis is symmetrical, so it doesn't change the direction of our parabola.